everybody. My name's Jack. I'm the editorial director of the Metaverse Insider. And it's a pleasure to be joined by Gerhard from Siemens today. Gerhard, would you like to introduce yourself and what you do at Siemens?
Thank you very much. I'm Gerhard Kress. At Siemens, responsible for the complete digital portfolio of Siemens Xcelerator and for the technology topics around that. So basically, we're trying to provide to our customers the best technologies for their digital transformation, help them go there faster and further on their journey.
And one of those technologies, digital twins. Can you explain to our audience and define kind of what digital twin is? Because I think there's a lot of misconception in the industry at the moment about what actual digital twin is. And interestingly, I jumped on call with Alex Howland from Verbella the other day, and he was talking about how actually a lot of digital twins are actually digital cousins because they're not one-to-one replicas and using data to enrich it. So can you define digital twins for our audience so they can get a brief understanding?
Yeah, so first of all, digital twin, of course, is a term that was coined recently, but the topic already exists for a much longer time. And for us, a digital twin is the digital representation of a physical asset or a system. Now, of course, the question is, how good does that need to be? It needs to be accurate enough for the type of questions you're asking. So it will be never one digital twin, but different variations, what you need to do. Important for me, it's a representation of the reality, including with the system dynamics. If you do a change in the digital world, it actually shows you what's going to follow from that. So if you change the positioning of a machine in a production process, it shows you how throughput changes, how maybe quality of the outcome changes, something like that. If you create a digital twin, you can create them on one hand side purely in a digital form, by taking an engineering tool, for example, to design an asset, to design a system, a process. But then you need to reflect it back to reality and saying, what am I predicting? What's the system supposed to do? What's doing in reality? And that delta gives you an insight. It can be that your simulation is not good enough, but it can also be that there are effects happening in reality that your system doesn't reflect. For example, you want to understand the behavior of a large driver motor. You could do that by putting up hundreds of sensors, measuring very quickly turning magnetic fields, or you actually have a digital twin running in parallel in real time, where you look at what's the real motor doing in terms of current coming in and torque coming out versus what's your digital twin creating. And then you see from that delta, you see degradations, for example, that you couldn't model before. And then you know when that motor is getting out of tolerance, you need to change something in the settings to make sure it still does exactly what it's supposed to be doing.
And of course, one of the main benefits of digital twins is sort of mitigating against risks. So you can fully optimize digital twin before, say, of a particular manufacturing product or factory before it comes into existence. Would you say that is one of the benefits?
So I see four areas where digital twins are playing a role. Area number one is when you design and engineer an asset, or so let's say create a product, a car, chassis, or whatever, something like that. So you can optimize that before you start building it, and you can optimize it without having to build many prototypes on the way. That speeds you up a lot, and you can take out weights, look at vibration, behavior, and stuff like this. Second big thing is you optimize your production process before you build it. You create a complete factory optimized for that purpose, making it smaller, more throughput, less energy consumption, so on, before you build it. And then you start putting the machines in. The third thing is you actually have an established production process and you optimize that. For example, you get supply chain problems. How can you react the best way when a certain piece isn't coming in? How do you change your process so that you're still running at near full capacity? And the fourth thing is you're servicing your asset after it's been delivered to the customer. You make sure they get the most value out of it. So in those four steps, the twins play an enormous role because they give you a way to experiment without having to do that on the real thing. And if you look into industrial assets, there's something very special. They last very long. They're very capital intensive, but they also have very few failures. So in the first 5-6 years of an average asset life cycle, a failure will be first of its kind. You cannot just say, I'm learning from the past. Well, you can, but it takes you many, many years. So if you want to be faster in that, you need to have little twins giving you an outlook how reality is going to be like. So these are the 4 areas where we focus on a lot, and the impacts are dramatic. We built a digital factory in Shenzhen where we get 30% more output at 40% less space and 20% less energy consumption. So it's a complete game changer. We implemented very simple digital twins in one of our own factories in Germany, in Bad Neustadt, and we actually got 5 percentage points more efficiency increase per year. That is a complete game changer in a very simple machining factory. We machine metal elements. Thousands of our customers have the same setup. That's massive. Most of the things you see, we see that lead times to produce a product, a car, went from a couple of years down to 9 months, what we're seeing today. Because you can test that, you can test the factory process without any issues. We're seeing that you get more lifetime out of an asset at less investment. In the rail space, we're so far that we can guarantee availability of trains, which means you can do the same amount of passenger journeys with 5 to 10% less trains. That's a massive impact. Just because you use a digital twin plus good processes underneath and handling that data.
Yeah, we've seen it with one of your partners, NVIDIA, and their Omniverse.
Exactly.
They've seen considerable dollars in cost improving operational efficiency. So I think is incredible, really, for some of their test use cases. One thing I wanted to ask you was, you recently released your industrial metaverse report, which was fantastic, really great. And you estimated the industrial metaverse to be worth 100 billion by 2030. Do you think that number is a number that is a low estimate, or do you think it's likely to go far beyond?
Well, in every of the, so we're trying to estimate the market that isn't there yet. But if the past tells us anything, is whatever we had an estimate of how much economic value such technologies create, we usually completely underestimate that. Because today we're looking at what we know right now. What we have not factored in is there's so much more innovation around it. Once that technology gets available and people get their hands on it, they create more and more and more ideas. So I would expect the number to grow dramatically over the next couple of years. That's what's important, to showcase a couple of real tangible cases very, very early. We have already up and running, so that captures the imagination of creating more innovation out there. I'm sure we have not captured a vast portion of what's possible.
Yeah.
Because we couldn't think of them.
And obviously, like, data plays a huge role in, simulating digital twins and the technology that underpins the industrial metaverse. And during some of our conversations that we've had at the summit, specifically with Rolls-Royce, they came over to us and said, actually, data underpins the industrial metaverse and is actually one of the core components of when you're building these stacks of technologies. Data has to be at the bottom of that on the start with. Is that true? And how important is data in building digital twins?
So that there's 3 parts. The first part is you need to create the digital model of that asset of the process. For that, you need a lot of metadata. Take an example. I'm creating a production process somewhere. There's machining systems in there from all the different machine suppliers. These systems need to communicate their capabilities. Otherwise, you cannot create a digital twin of that process. So there's a lot of metadata in there. Once I have that system running, I always need to calibrate or recalibrate and seeing, is that what our system is saying, our digital twin is saying, how close is that to reality? Because you can never have 100% realization of reality. There will always be some part that you haven't thought of. Some effects, second order, third order, fourth order that you haven't thought of. So you need to get that reality as well. And there's always some statistical fluctuations, like certain failures that are happening because there was an undetected small crack somewhere that nobody ever looked at and we didn't know was relevant. So data is very important to make sure our digital twin reflects reality. But you need both. If you don't understand the system behavior, the data doesn't tell you much. If you only have data, but no system behavior attached to that, you can't do a prognosis.
And finally, I think one of the things that stood out to us at Metaverse Insider with your report was how you segmented the industry from industrial, social, and enterprise. And considering the metaverse industry is one that finds it difficult to actually define itself in first instance, I thought that was brilliant. I thought that was really fantastic, and that's something actually that we're going to be, trying to follow your lead in that regard. I think what would be really useful for audiences, if you could define the difference between enterprise and industrial, because I think a lot of people get confused between those two terms, enterprise metaverse, industrial metaverse.
Well, for me, the industrial metaverse is basically, we're looking at processes that we consider industries. It could be production processes, can be building operations, it can be infrastructures like power grids and so on. So all those things that where we're really dealing with physical assets as the main part that are creating the action, basically. On the enterprise metaverse, it's about people in an enterprise setting. We're talking about enterprise processes, we're talking about financial process collaboration in an enterprise setting, which is different from the consumer metaverse, and mostly because of the decision-making points. In the B2B setting, the type of arguments you need to put on the table so that somebody adopts it are very different than in the consumer setting. Remember decades ago when Nokia introduced that telephone with that flip cover, and Siemens had great phones. In a B2B setting, that cover didn't make any sense, but people loved it. So decisions are taken differently, and therefore I think there's going to be a different dynamics in there. Why people want to do something. The industrial metaverse is different from my perspective because you can target really outcomes in industrial process. You can make sure that whereas renewable energy is coming into the grid stays stable. We're not going to get a blackout.
Yeah.
That's something has an inherent value. That's not do I like or dislike it. It solves a problem. Therefore, I believe that the industrial metaverse will be much faster seeing adoption in the real space because it solves real problems. And this is why I'm always saying the industrial metaverse is not something that we're talking about a vision 10 years down the line. We're talking about real things you have today already that you can use, that you can buy, that can make your life better. But we're going to broaden the scope. And we talked in the panel about interoperability. That is not yet there. It will arrive. But you don't have to wait for everything to be interoperable to already have the first part where you get real value. And therefore, I believe we're going to see adoption much sooner.
I totally agree. I think, on the social side, it's something that's going to come into practice in really many years to come, at least from blockchain, decentralized point of view.
Yes, but I think the dynamics of adoption are very, very different. And I don't understand the dynamics good enough in the let's say, consumer world to say how it's going to happen.
Yes.
That will have many different aspects and different groups, subgroups, taking on different stands. But when you have a clear ROI attached to something, that will be the first technology is not being adopted when it creates value. I don't think we're going to see that not being adopted.
Agreed. Well, that's been an incredibly insightful conversation. Thank you, everybody, for joining.
Thank you very much.
Thank you.